about the preparation of carboxylic acids. How do we prepare carboxylic acids? We have 10 methods that I'm going to enlist first over here. So first is the reaction of Grignard reagent with carbon dioxide. The second is hydrolysis of alkane nitrile. The third one is oxidation of alkyl benzene. Fourth one is oxidation of alcohol, be it 1 degree or 2 degree alcohol. Then we are going to be seeing the acetylene addition reaction, and then we're going to see the hydrolysis of esters, and then we're going to see the hydrolysis of that's hydrolysis of acetyl chloride. And then what we have is the oxidative cleavage of alkenes, and then these are the two reactions over here. So let's move on and start with the first reaction, which is the reaction of Grignard reagents with CO2. We might place it over here, and then what we'll see is that a Grignard reagent, for example, let's just take alkyl magnesium bromide or methyl magnesium bromide, and then we react it with carbon dioxide. What's going to happen is this one carbon is going to react with this one carbon, and then it's going to form ethanoic acid, and then this is going to form carboxylic acid. So that's the reaction. So moving on, we have the hydrolysis of alkane nitrile. What we'll see is, if we have, let's just say that the common naming of nitrile is, we don't count the CN. So what we do is, we say it as like alkyl cyanide. For example, if we have C2H3 C double bond N, C triple bond N, we would say it as ethyl cyanide, and not as, and the IUPAC naming would be propane nitrile. Now if we see that alkane nitrile, let's take an alkane nitrile, C triple bond N, and then we react it with water in the presence of HCl. So it occurs in acidic medium. What we'll get is the IUPAC naming. So what is the common naming of it? What if on the exam the common naming is present? What's the common naming of it? Is propyl cyanide or butane nitrile. What's going to form is butanoic acid. Now moving on, we see the oxidation of alkyl benzene. How does it occur? It occurs in the presence of alkaline potassium permanganate. So what's going to happen is, if we take a benzene ring over here, we will see it also. So what we have is alkyl benzene, for example, methyl benzene. We're going to react it with oxygen. So for methyl, we may take 3 oxygen. For ethyl, we may take 6 oxygen, and so on. For propane, we may take 9. So we take 3 oxygen over here, we use alkaline KMnO4, and then what we form is benzoic acid. And now moving on, we have the oxidation of alcohols, be it 1 degree or 2 degree alcohols. So if we take alcohol, for example, methanol, ethanol, which is a 1 degree alcohol, we see that it reacts with oxygen. The oxidizing agent used is K2Cr2O7 in the presence of concentrated H2SO4. So what's going to happen is, it's going to form, so 1 degree alcohol will form aldehyde, and 2 degree alcohol will form ketone. Now this will further oxidize and form carboxylic acids. So what is going to form is acetaldehyde, and then this acetaldehyde, in the presence of same reagents, is going to form acetic acid or ethanoic acid. Now, for example, if we have propanoic acid. So the 2-degree acid, propan-2-ol, for example, we have propan-2-ol or 2-propanol. It's going to react with oxygen within the same reagents. Concentrated H2SO4 K2CR2O7 is going to form acetone or propanol or dimethyl ketone. And then this is going to react with the same reagents, and then it's going to form mixture of carboxylic acids. So if we have like a metamerism effect, for example, if we have unequal distribution of carbon on either sides of the functional group, what's going to the carbonyl carbon is going to favor the side which has lesser number of carbon atoms. So for example, this has 1 carbon atom, this is 2 carbon atoms. So it's going to form acetic acid plus this is the propanoic acid. So now moving on, we may see the acetyl addition reaction of acetylene. So if we have an acetylene over here, which is simply ethine actually, and then we react it with water in the presence of 10% H2SO4, what we get is carboxylic. So what we form over here is it's going to do the famous reaction that involves the mercuric sulfate and HDSO4 and H2SO4 or K2CR2O7. So what's going to do is it's going to form a vinyl alcohol. So this is a vinyl alcohol. Now it's going to undergo tautomerism or rearrangement. So what's going to happen is this hydrogen is going to shift here, this double bond is going to shift over here, and what will form is an aldehyde, which is acetaldehyde. Now this acetaldehyde may undergo reduction in the presence of K2CR2O7 and H2SO4 concentrated and form the corresponding carboxylic acid, which is acetic acid. Now moving on, what we have is hydrolysis of esters. So if we have an ester over here and we use water to hydrolyze it, what we may get is an alcohol and carboxylic acid. So the hydrogen is going to take up over here, the OH is going to take up over here, and we may form alkyl alkanoate. Alright, so one thing to note is that this rule, the addition rule, may apply to all other formation of carboxylic acid except formic acid, and the oxidation of alkyl benzene is also called side chain oxidation reaction because this side chain is oxidizing and not the ring which is the parent. And then the oxidation of alcohol, for example 2-degree alcohol, this one is a 2-degree alcohol. So if we form symmetrical alkene, the symmetrical ketone, it's not going to form mixture of carboxylic acid, but if we have an unsymmetrical ketone, it will form the mixture of carboxylic acids. The carbonyl carbon will favor that side with lesser carbon atoms. So then we have, I explained that the 10% H2SO4 is actually 10 ml H2SO4, 90 ml of water, and the vinyl alcohol is also called the keto enol or anything like that. And the hydrolysis of esters, so for hydrolysis of esters, the general formula of esters is alkanoate. The alkyl group is going to be taken as OH, and the alkanoate is going to be named after the carboxylic acid. So what we have over here is ethyl butanoate, which is a pineapple. So it's actually also a test which is done in the lab that pineapple scent is given off, pineapple smell is given off by ethyl butanoate under reaction with water in the presence of concentrated H2SO4. Now hydrolysis of esters always occurs in acidic medium. So what we'll have is ethanol and butanoic acid. Okay, so moving on, what we have is hydrolysis of acetyl chloride. So what we'll do is we have acetyl chloride, for example RC double bond OX. For example, we have ethanol chloride. And that's going to react with water, and then it's going to form acetic acid. ethanoic acid. Now moving on, what we have is the oxidative cleavage of alkene, which is I think the last step. So it occurs in the presence of hot KMnO4. Now this is a tricky part, that what we have is an alkene, for example. Only these will form. So for example, this one has 2 carbon, this one has 2 carbon. These will combine to form 4 carbon. Now this 4 carbon will divide into 2 and then it will form 2 corresponding carboxylic acids, meaning 2 moles of carboxylic acids. So for example, if we have, actually that's alkene. So what we have is N hot KMnO4. It will form 2 of the acetic acid molecules.